Hi there. I'm Aditya Asgaonkar from the Ethereum Foundation's research team. In just 10 minutes, I'm going to share the top 4 things to know about Ethereum proof of stake. So first off, let's talk about the elephant in the room, energy consumption. We know proof of work to be extremely wasteful in its energy consumption. In fact, when you mention proof of work, I can't help but think about large industrial mining farms. With the shift to proof of stake, Ethereum is doing away with the proof of work, energy-intensive mining. Let's have a look at its energy consumption. So if the scale of the object were to signify its energy consumption, then Ethereum proof of stake is comparable to a screw. To put things in perspective, the Ethereum of today would be the Leaning Tower of Pisa. The shift to proof of stake marks a 99.9% reduction in power usage. And to look at the bigger picture, Bitcoin would be comparable to the Burj Khalifa. So, the tallest building on Earth, the Tower of Pisa, and a teeny tiny screw. And while we are on the subject of resource consumption, let's also look at the hardware resources required to participate in proof of stake. With proof of work, we know that you require expensive mining rigs to participate in the protocol meaningfully. But with Ethereum proof of stake, even regular laptops can run Ethereum staking software, thanks to the engineering efforts of some of our client teams sitting right there. Yeah. All right, so let's have a look at some home staking setups. On the right is a medium-sized home mining rig. 10 GPUs housed inside a cooling tent. In the bookcase on the left is a small square puck. That is a mini computer that can run Ethereum staking software. These Intel NUC class machines are quite popular among home stakers. And here we have a regular old Dell Optiplex being used for home staking. But my favorite setup of all is that of my colleague David's. His setup sits in the back of his RV. The computer is solar powered, and with satellite internet, he can stake comfortably from even the backroads of Colorado. Isn't that a great setup? And such a contrast from large mining rigs that are required for proof of work. Before we go further, let's talk about consensus, the engine that powers proof of stake. When research into the new proof of stake protocol began, the state-of-the-art consensus technology was what we call BFT consensus. In these processes, each participant must send a message to every other participant at each step of the process. As you can imagine, this gets quite expensive in the number of messages being passed around. In fact, the number of messages grow quadratically with the number of participants. And so these protocols don't scale well beyond the tens of participants. While there's been decades of research into these protocols, there has been no major incentive for massively scaling the number of nodes. But that was before the arrival of blockchains. With Ethereum proof of stake, we have the ambitious goal of supporting up to 1 million+ participants. And the participants here refers to the validators, not the users. There's no practical limit on the number of users. And while we are on the, sorry about that, and Ethereum scales massively without compromising on security. 34,700 ETH, that is the level of security in the beacon chain today. Let me explain further. In just 18 minutes after a block is produced, it is expected to become finalized. Once the block is finalized, it's impossible to remove it from the chain without bearing a large cost, the number on the screen. If an attacker attempts to revert a block, then their validators will be identified, and in the true spirit of proof of stake, their deposits will be burned. This notion of crypto-economic security is the strongest form of safety in blockchains. Let's have a look at how Ethereum compares with different protocols. Proof of work protocols such as Bitcoin and Ethereum today don't provide crypto-economic security, nor do protocols such as Avalanche. BFT-based protocols such as Tendermint don't provide the massive scalability, and don't make progress when participation rates are low. As you can see, Ethereum provides some unique guarantees to its users. And we believe this makes Ethereum suitable for the decentralized backbone of tomorrow. Now let's take a look at some of the future improvements we are working on. Faster confirmations. In just 12 seconds after a block is produced, a little over 3% validators make attestations for it. This amounts to about 13,000 in the Beacon chain today. We are exploring techniques to utilize these to provide a quick confirmation score, just like proof of work. This next one is something I'm extremely excited about. Distributed validator technology allows a cluster of nodes to come together and operate a single validator. This has the potential to enable trustless staking pools, where different entities come together and collaborate in running a single validator. This would reduce the capital requirements needed to participate in proof of stake. So to sum it all up, the 4 things to know about Ethereum. It is energy efficient, reducing Ethereum's power usage by 99.9%. And it delivers on the 3 pillars of the blockchain grail. It's highly secure, providing the strongest form of security known in blockchains, cryptoeconomic security. It delivers on decentralization by maintaining lightweight system requirements. You can participate in proof of stake at home on your regular laptop. And it's highly scalable, supporting up to 1 million+ participants. And with the roll-up centric approach, it will massively scale its transaction capacity as well. This is something Vitalik will talk about next. Thank you. That's all from me.